Assalamualaikum warahmatullahi wabarakatuh. Okay. Good morning, class. How are you? Great. I'm fine too. Thank you. All right. So before we start the class, let's pray together first. Pray. Begin. Finished. All right. After that, I'm going to check your attendance. Is everyone present or is anyone absent? Yes. Oh, everyone is present. Oh, right. Okay. So I see that everyone is present. That is cool. Okay, so the next I'm going to ask about something. What did we just learn last week? Anyone wants to answer? Yes? Okay, you're correct. Thank you. Good job. Okay, so last week we learned about introduction of physics. We learned about the definition of physics itself, its application in real life, and maybe its basic introduction in other things related to physics and so on. All right. So the today's material is about measurement. Measurement is related to the introduction of physics because measurement forms a very important part of physics. I mean, if we conduct an physics experiment, we need to measure a lot. Okay. So prepare your book, students. I'm going to explain from the definition of measurement itself. So measurement is a technique to determine the size or magnitude of a particular physical quantities of something or an object. For example, I have a wood stick here. We can measure its length, its mass, and its volume. Okay. Okay, after that, I'm going to explain about physical quantities, as I have mentioned before. Okay, so physical quantities is physical properties or characteristics of something or an object that can be measured. For example, I'm going to pick up the wood sticks again. Okay, so we can measure its length, its mass, and its volume using a specific instrument of measurement. For example, to measure length, we can use rulers. To measure mass, we can use a balance. May it be all-horse balance or triple beam balance, double beam balance, or digital balance. For its volume, we can measure it by using something like a measuring glass or other things. Okay, after that, I'm going to explain about um, a unit of measurement. Okay, so a unit of measurement is a unit that is used to measure a physical quantity of something. For example, I will pick up the wood stick again. Okay, so to measure its length, this wood stick's length, we can use units like meters, centimeters, and so on. Or maybe if we want to measure a length of the road, we can use kilometers, miles, and so on. To the to measure this wood stick mass, we can use units like kilograms, grams, and so on. If the object is very heavy, we can use tons instead. Okay, so another example is we can measure this volume by this wood stick volume by using like cubic meters, liters, centiliters, and so on. Alright, so there are two kinds of units of measurement. For example, the first is base units. Base units is units that is standing on their own and do not depend or consist of other units. There are seven base units. Okay. So there is length, there is mass, there is time, there is temperature, there is number of substance, there is luminosity, and there is like temperature. Okay, so length is measured by meters in international standard or SI. Time is measured by second in international standard, and um, temperature is measured by Kelvin in international standard, and the number of substance is measured by moles. Luminosity is measured by candela. I'm sorry, and and the electric current I forgot to mention that before. I'm sorry, students. Is measured by amperes, and the last temperature is measured by Kelvin. Or okay, in both all in international standards. All right, so okay, aside from that international standard units, these seven base units can be measured by other units like, for example, length can be measured by meters, kilometers, and so on. Temperatures can be measured by using like Reamer, Fahrenheit, and Celsius, degree Celsius. Time can be measured by hours, minutes, years, decades, and so on. All right, so okay, after that, I'm going to explain about the instrument of measurement. An instrument of measurement is basically an instrument that is used to measure a physical property of something. For example, to measure this wood stick's length, we can use rulers. To measure its weight, its mass, we can use like triple beam balance, double beam balance, digital balance, and so on. To measure this volume, we can use like measuring glass or and so on. Okay, the next is about the system of measurement. So a system of measurement is a collection of several or maybe many units, both base units and derived units that are related to each other and are connected to each other by a series of rules. Like a storyteller that connects their own created main points into a story by using this story story framework or something like that. Okay. So there are currently three systems of measurement that are widely used in the world. The first is metric system. Metric system use decimal numbers to measure physical properties. Metric system is used in most countries in the world. System This system of measurement consists of units like meters, kilometers, kilograms, tons, grams, second, and so on. Okay, so the second system of measurement is the imperial system. Imperial system, as the name suggests, is used in former imperial countries like United Kingdom and its colonies. Imperial system consists of units like long tons, miles, and so on. The next is the U.S. customary system. As the name suggests, the U.S. customary system is used in the U.S. and its overseas territories and maybe states. Okay, so the US customer systems consists of units like miles, short tons, gallons, and so on. US gallons, so on. Okay, so the next is about um, scientific notation. Okay. Scientific notation is used to express a very, very large number, a very, very small number. I mean, if we read some we read a number, for example, like 1 trillion, we can just call it 10 power 12. So the examples of scientific notation is first the astronomical unit. Okay, so an astronomical unit is around 150 million kilometers or 150 billion meters, or we can just call it um, 1.5 times 10 power 8 kilometers, or 1.5 times 10 power 11 meters. Way shorter, right, students? Okay. So the other example is light year. One light year is approximately 9 billion and 9 billion 500 million kilometers, or we can just call it 9.5 times 10 powers 12 kilometers. Okay. Another short example. Okay. So the next example is dyne. Dyne is a force, a unit of measurement to measure force. One dyne is approximately 10 powers negative 5 newtons. Or we can just, okay, I mean when 0.00001 newton. Or we can just call it 10 power negative 5 newton. Very short, right? Okay, so the last another example of scientific notation is um, angstrom. Okay, angstrom is a unit of measurement to measure length. Okay, so one angstrom equals approximately 10 point negative 10 meters. I mean, sorry, I mean that's that's the scientific notation. It's actually 0.000000001 meter, or we can just call it, as I have mentioned before, 10 power 10 powers negative 10 meters. Very short, right? Okay. Okay, so the next one, I'm going to explain about sorry, I forgot. Let me think for a bit. Students, I'm sorry. Mm, meters. I forgot, student. Anyone remembers? Okay. So mm, measurement. Okay. No, measurement. My student, I couldn't remember. Um, oh yes, it's about significant numbers. I'm sorry, students. I'm sorry. Okay, so significant numbers, as the name suggests, is significant figures. Oh, I mean significant figures. That is figures or numbers that are significant or important in the result of measurements. So because it is usually present at um, physical measurement, it is an approximate value of measurement, not its exact numbers. Okay, so like if you measure these wood sticks, for example, this wood stick's length is about I'm 14 centimeters. 14 centimeters. Maybe it's too short. It's this wood stick is probably around I mean like 50 or 60 centimeters. Okay, so for only just for example. Okay, so for example, 14 centimeters. Okay, 14 centimeters consists of two two significant figures. Why two? Because there are 1 and 5. 1 and 5 is a significant figures. Basically, all of non-zero digits is a significant figures. Okay. For zero top, things are a bit more complicated. Okay, so these complications are explained in a few rules. Okay, so the first rule of significant figures are all non-zero digits is um all non-zero digits is significant figures as I have explained before. For example, 15.2. 15.2 consists of three significant figures, that is 1, 5, and 2. Another example is 111.3. There are four significant figures, namely 1, 1, 1, and 3. Okay, so the next rule is any leading zeros, all leading zeros in a decimal number is not significant figures. For example, 0.0003 consists of only one significant figure, so we don't include the four zeros in the front of 3, in the left of 3. Another example is 0.0123. So there are only three significant figures, namely 1, 2, and 3. The two zeros in the left of 1 is not a significant figure. Okay, so the third rule of significant figures is that any zero between that is located between two non-zero digits are considered significant figures. For example, 100 and 102,000 and 102,878. Okay, so the zero between 1 or 2, I don't remember. It's basically 2 or 8. Okay, so the zero between 1 and 8 or 2 is a significant number, a significant figure, because it is located between two non-zero figure or digit. Okay, so the last rule is any zero that is located in the right of any non-zero digit in a decimal number is considered significant figure. For example, 18.870. Okay, so there are five significant figures, or all of the number of the digits there is a significant number. The zero in the rightmost of the number is considered uh, a significant number. Another example is 0.0002350. There are four significant figures, that is the 2, 3, 5, and 0 in the right of 5. So we don't include the four zeros before in the left of 2, because they are not significant figures. Okay, so the next rule, there are too many rules. Okay, so the next rule is, in a scientific notation, the numbers considered to be significant figures is it's only the non-zero digits. I mean, beside 10. For example, 2.54 times 10 power 10. The only significant figures are 2, 5, and 4. The 10 power 10 doesn't include it because it is a number that number that like number that symbolize the number of zero. Okay, so the next example is 3.70 times 10 power 9. There are only three significant figures, that is 3, 7, and 0. Again, the 10 powers what 9, it is not included. Sorry, 10. Sorry, 10, all right. Okay, so the next is about the operation of significant figures. I'm going to explain about times. For example, 10 times 10 is 100. I mean like that. So in a multiplication of two significant figures, the number of significant figures in the result of the multiplication is the same of the number of significant figures in the in the in the number in the multiplying factor that has the smallest number of significant figures. For example, 12.70 times 3 is the result is, according to the rules, is wait, let me count first. 2.1, 2, all right, so the result is actually 40. You may think that the result is actually 38.0, but it is actually 40. Why? Because in the multiplying factor, there are two multiplying factors like 12.7 and 3. The multiplying factor that has the smallest number of significant figures are 3, which means the result has to be 1. I mean, one one significant figures, that is 40. 40 has one significant figure, so like only 4. The 0 doesn't count. It's only 0. All right, that's all from me, students. I'm going to open a chance for you guys to ask about today's materials. Okay, so is anyone want to ask? Right, anyone? Okay, no questions. All right. So if there is no questions, let's conclude the material today. Anyone wants to conclude the material today? Okay. No. Right. I mean, this is a very basic material, so it doesn't have to be concluded, right? Okay, so okay. That's all from me, guys. Thank you very much. Before we end the class, let's pray together again. Pray, begin. finished. Okay, that's all from me. Thank you for your attention, students. See you in the next week. Assalamualaikum warahmatullahi wabarakatuh.